component and x component is already found. So tan inverse of 8 by 66 divided by 12, your answer is equal to 35.81. So your magnitude of resultant is 14.79, phase angle is 35.81, it is positive. So you can write the equation for resultant like this: IR is equal to 14.79 sin omega t plus 35.81. Here it is positive, so you have to write down plus 35. If it is negative, you can write down minus 35.81. It will indicate lagging and leading of the resultant current. Now next example. Again 3 currents are given to you. First I1, which is equal to 10 sin omega t, I2 is equal to 20 sin omega t minus pi by 6, and I3 is equal to 30 sin omega t plus pi by 4. First current 10 sin omega t means reference from reference angle the current angle of I1 is equal to 0. For second current it is given omega t minus pi by 6. It will indicate the second current is lagging from the reference axis, and third current is omega t plus pi by 4. It will indicate it is leading from the reference axis. So this is the vector representation of the given current. This is the first current OA, angle is equal to 0, magnitude is equal to 10, so here it is OA. For second current, angle is equal to minus pi by 6, so here it is 30 degree minus, so it is lagging, and magnitude of it is 20, so the magnitude of OB is equal to 20, angle is equal to minus 30. Now OC, again angle is equal to plus pi by 4, so here it is plus 45, and the magnitude is equal to 30. So this OA will indicate the I1, OB will indicate I2, and OC will indicate I3. This is the vector representation of alternating quantity. Now we are finding the resultant of it. Now first of all we have to find the x component and y component of all the 3 currents. So first of all we are finding the x component, which is equal to OA plus OB cos 30 plus OC cos 45. OA, OB and OC is nothing but the magnitude of the current which is given in the data. So OA is equal to 10, OB is equal to 20, and OC is equal to 30. So our equation is like this: it is equal to 10 plus 20 cos 30 plus 30 cos 45. So your final answer is equal to 48.53. So it will give you the value of x component for all the 3 currents. Now we are finding the y component. As shown in figure, for OB, if you are take the projection of OB on the y-axis, so it will give you the negative y-axis. Whatever the value, it is negative. So whenever you find the y component for OB, then you have to consider a negative sign over here. So here it is minus OB sin 30, because this is lagging current. If it is leading, then here it is positive. Because this is the lagging current, so here it is negative. So it is equal to minus OB sin 30 plus OC sin 45. OB is equal to 20 and OC is equal to 30. So your equation is like this: it is minus 20 sin 30 plus 30 sin 45. So it is equal to minus 10 plus 21.21. So your final answer is equal to 11.21. So magnitude of x component and y component is known to you. Now you have to find the magnitude of resultant current. Equation is again known to you, which is equal to under root of x component square plus y component square. Value of x component and y component is known, which is equal to 48.53, and y component is 11.21. So your magnitude is equal to under root of 48.53 square plus 11.21 square, and your final answer is equal to 49.81. Now phase angle of a resultant current, again it is tan inverse y component by x component. So it is equal to tan inverse 11.21 by 48.53. So your angle is equal to 13 degree. So your final equation for resultant is like this. It is 49.81 sin omega t plus 13. This plus 13 indicate your resultant current is leading by a reference axis, and angle from the reference axis to the resultant current is 13 degree. Now another example. 4 voltages are given by E1, which is equal to 5 sin omega t plus pi by 6. Second E2, which is equal to 7 cos omega t plus pi by 3. Third E3, which is equal to 3 sin omega t minus pi by 4. And E4, which is equal to 10 sin omega t minus pi by 6. Now first E1 having a positive angle, which is plus pi by 6. E2 also having a positive angle, which is plus pi by 3. It will indicate that both the current are leading. While E3 and E4 having a negative angle, it will indicate both the currents are lagging. So whenever you draw a vector representation of alternating quantity, always keep in mind the positive and negative sign of the angle, and after that draw the vector representation. Okay. As shown in diagram, first OA will indicate E1 vector, and the magnitude of E1 is 5 and angle is plus pi by 6. So here angle is equal to 30 degree and magnitude is equal to 5. For E2 it is given like this: 7 cos omega t plus pi by 3. As we know, the instantaneous induced EMF or instantaneous induced voltage equation is in form of sine only, but here it is given in form of cos. So first of all you have to convert it into a form of sine and then draw the vector representation. So here E2 is given 7 cos omega t plus pi by 3. As we know, cos theta is equal to sine 90 plus theta. So 7 cos omega t plus pi by 3 is equal to 7 sine pi by 2 plus omega t plus pi by 3. So your equation is like this: E2 is equal to 7 sine omega t plus 150. So whenever any equation is given in form of cos, first of all convert it into sine and then find the resultant. So here E2 is equal to 7 cos omega t plus pi by 3, which is converted in sine. So your final equation is 7 sine omega t plus 150. So this is the vector representation. First is the OA, angle is equal to plus 30 degree. Second vector is OB, which is equal to 7 cos omega t plus pi by 3, which is rewrite like 7 sine omega t plus 150. So angle from the reference axis is 150. So this is our 150 degree, and OB is equal to 7. Magnitude of the second vector is 7. So magnitude of this vector is 7 and angle is equal to 150 degree. For third one, angle is equal to minus pi by 4. So angle is equal to minus 45. So this OC will indicate the angle is equal to minus 45 and the magnitude is equal to 3. Next is fourth is 10 sine omega t minus pi by 8. So again it is lagging current, magnitude is 10. So this OD will indicate that the magnitude of current is 10 and angle is equal to minus pi by 8, which is equal to 22.5. So this is the vector representation of all the 4 voltages. Now you are find the resultant voltage. So again same method, you have to use the resolution method. So E2 is equal to OB is equal to 7 and phase angle is equal to plus 150 degree as shown in figure. For E3 magnitude is equal to 3, which is represented by OC and having a phase angle of minus 45, and for E4 which is represented by OD, magnitude is equal to 10 and having phase angle of minus 22.5. So now we have to find the X component of all the 4 currents. First it is OA cos 30 minus OB cos 30 plus OC cos 45 plus OD cos 22.5. Now for second current, this is our second current OB. If you are take the projection of OB on the x-axis and y-axis, so it will give that for x component you are having a negative value and y component you are having a positive value. So whenever you find the x component of OB, it is negative. Same way for OC and OD, if you are take the projection from x-axis and y-axis, then the projection of OC and OD to the y-axis is negative, but on the x-axis it is positive. So whenever you find the x component and y component, always keep in mind the location of vector, and after that consider positive or negative component according to the given angle. So for E2 or for OB, your x component is negative, and for OC and OD your y components are negative. So whenever you find the x component, this is our x component, we are consider here negative sign minus OB cos 30, because the x component of second voltage is negative and all the three are a positive value. So here OA, OC and OD are the positive values, but OB having negative value. So it is rewrite like this: 5, which is magnitude of OA cos 30, minus 7, which is magnitude of OB cos 30, plus 3, which is magnitude of OC cos 45, and plus 10, which is magnitude of OD cos 22.5. So which is equal to 4.33 minus 6.06 plus 2.12 plus 9.24. So your final answer is 9.62. Now for y component, as we are discussed earlier, for OC and OD negative values are there for a y component. So here it is negative, here it is negative. So your y component is OA sin 30 plus OB sin 30 minus OC sin 45 minus OD sin 22.5. So it is like this: 5 sin 30 plus 7 sin 30 minus 3 sin 45 minus 10 sin 22.5. So it is equal to 2.5 plus 3.5 minus 2.12 minus 3.82, and answer is equal to 0.0517. This is your y component. Now magnitude of resultant equation is known to you, which is equal to under root of x component square plus y component square. So it is equal to under root of 9.62 square plus 0.051 square, and your final answer is equal to 9.62. Now phase angle. Phase angle is equal to tan inverse of y component by x component, which is equal to tan inverse of 0.051 by 9.62. So your answer is equal to 0.31 degree. So your final equation for a resultant of voltage is represented like this: ER, which is equal to 9.62 sine omega t plus 0.31. 0.31 is the phase angle of the resultant voltage and 9.62 is the magnitude of resultant voltage. So this is the vector representation of alternating quantity. Now we are revised this session like this. If you have to represent any alternating quantity by a vector, then you have to fulfill three conditions. First condition is that the amplitude of the alternating quantity should be equal to the magnitude of the vector. Second condition is that if you have to represent the alternating quantity by a vector, then your alternating quantity should be start from the zero value and increasing in a positive direction. Then only your rotating vector will rotate in an anti-clockwise direction. If you are reverse the direction of alternating quantity, the direction of rotating vector will be reverse. And third condition is that if you are selecting any alternating quantity, then when your alternating quantity will complete one cycle, your rotating vector should complete one revolution. Means the angular velocity of the rotating vector should be equal to the frequency of the alternating quantity. Okay, we stop our session over here. In next lecture, we will discuss about the behavior of alternating quantity for a resistive, inductive and capacitive circuit. Okay, thank you.